Okay, good morning. How's everyone doing, man? It's been a long week, huh? So I get the Friday morning session after everyone's brain is just full of stuff, and a whole bunch of people want to get out of here, so before the moss starts growing on the back of their neck, I understand that. But so what we're going to do this morning is I've got basically 3 stanzas in this talk, and we can go pretty much wherever you want to go. And I'll run you through that. I'll actually ask for some audience participation so you can let me know where you want to take things. So the 3 stanzas are sort of describing the landscape of what's happening in storage, the big data, MapReduce, NoSQL, column store, graph store, what's going on there. And I've spent a fair bit of time over the last few years sort of wrapping my head around that and figuring out how we should respond sort of product-wise. I've got a stanza in which I can explain sort of what's behind the whole big data phenomena. Where's the new value actually coming from? And it kind of spans from comparing workflows that we've done traditionally in systems, and then how things are different in the big data world. And then I've got the MapReduce drill down, where we can talk about the concepts, and I've got code and stuff I'll show you from there. So here's its audience participation, because it's late, it's Friday, and so show of hands, how many people would like A, sort of top of the list, describe the landscape, how to decide? You got anyone? You got a few of those. Okay, that's pretty good. Show of hands for B, sort of what the heck's up with all this big data stuff? Where's the value there? Okay, yeah, that's pretty good too. And then C, sort of the MapReduce, drill down, do some code and such. Okay, so it looks like A, and then B and C. Okay, all right, good. You guys passed the first quiz. Second quiz is I'm not going to go anywhere until I get 2 specific questions from someone. And I'll make it easy because I'll frame the question. Just shout it out. A question, and if you want to walk out of the room, say in 60 minutes, having an answer to something, some question you don't have right now, what would it be? And someone just throw their hand up and ask, because I'm not going anywhere until someone does. So someone's got to be the first penguin. Yeah, in the back, and I'll repeat it. Sure. So pricing when I describe options. Absolutely. And if I don't do it to your satisfaction, you let me know. All right. We'll go back. Yeah, up front.
Yeah. When trying to decide between data options, what's best practices? Like, why did you make that choice?
Okay. So great. Best practices around how to decide. Sure, that's in there. I thought I saw one. I would take 1 or 2 more to make sure we're on this. Yeah. Best ways to access the data. Okay. Good one. In the back there, right there. Yep. Connected, disconnected. I don't have too much of that in the slides, but I'll try to remember putting that in an appropriate place. If I don't, I'll try to ask me in the questions at the end. Yep. Yeah, regulations like HIPAA and all the other stuff that keeps me up at night. So yeah, that's that one I try to repress, but since you brought it up. Okay, good. Thank you. That'll help me sort of tune this. So I see some folks out there who've probably been doing this for some time, like me, and probably remember all the way back to the days of VB when life was simple. We had a database underneath us. We had we called it forms over data, and it was about that simple. Life is no longer as simple. I could have thrown about 5 times more stuff on this slide. But this whole, I think about it real simply, is evolving from client server to device cloud. And you've seen a lot of that this week. The other thing which I think is very pronounced is this notion of multi-dimensional experiences and what the implications are and how I design sort of the information model for an application. And by multi-dimensional, I mean you have many applications today which consist of rich client aspects or perspectives, web projections, mobile projections, and they're not just different size UI, different size screen, different things that you can do. So think about geo reminders. Can I schedule a set of reminders on a rich desktop app that when I drive within a half a mile of the hardware store and I'm not racing to some other appointment, can I get a notification telling me to go in and pick up the nails I need for the project this weekend? Multidimensional. The other multidimensional aspect is to think of devices as constantly collecting data and how you can make use of it. So one of the things, actually I'll get to this later on, this is a GPS data logger I've been carrying around for about 1.5 years. And I gave a talk last August at what it was kind of ironically the Very Large Database Conference, and I did a keynote, and the title was, "Is it still big data if it fits in your pocket?" And the point was to illustrate many of the patterns sort of at megabyte scale, and we'll get into that sort of the tail. Social integration, everyone gets that. And then this notion of rapid evolution. And we are facing that ourselves in our product development. I've been at Microsoft for 18 years, been working in and around SQL Server for most of that. And we were used to doing things on the cadence of every couple of years, 3 years, whatnot, ship something up. In the Azure world, in the back-end services world now, we are turning things daily, weekly, and it is an amazing shift. And the ability, if anyone saw the keynote on Tuesday, to listen to what the service is saying and refine it is very, very important and very much where a lot of the value can be realized from this big data stuff. And I think we'll connect that end to end at the end. And volatile scale, certainly everyone knows and has lots of illustrations of that. So that's sort of the world we live in. And as a result, there's just been this explosion of storage and data management systems for this new world. Now, I am old enough and have been in this industry long enough to have actually kind of predated relational. And for those of you who remember a company called DEC way back when, I worked for them. All right. And before working on RDB, their relational database product, I was actually the project lead for DBMS. So the old-time database folks who know something about codicil data model predated sort of our relational product and actually still ship for quite a while with it. And so a lot of evolution. And the relational database has sort of held steadfast for a number of decades. Now, there are a whole bunch of things happening. And there was a lot of noise that broke out a couple years ago relative to the NoSQL movement. And we had people inside our group just completely dismissing it. And I said, hold on, let's try to figure out where the perceived value is. Where are people believing, where are they trying to achieve new value? Are they achieving it? And what's the best way for us to respond? So what I want to do is to just kind of run you through that in a thoughtful way here in the next 7 minutes to arm you so that the choices, how do I make a decision here? And so that's what we'll do. So here's what I've come to believe. What developers want in this world is rapid development and evolution. They want a form of persistence ignorance, which is about, I have a domain model in my head around how the information model in the application works, and I don't want to go through a whole bunch of hurdles to try to get that into the database, not particularly when I don't have other uses out of it where I'm going to get a ton of value. Schema evolution, dynamic schema in this new world, incredibly important. Just to illustrate for some of the newer folks how things have changed in 20 years. When I was at DEC before coming to Microsoft, one of the last large systems that we worked on for a customer was a billing system for a satellite TV provider. And we worked on that thing for 2 years and knew every single transaction, how many IOs it was going to be. And that, in that world, you had to be that careful because resources were scarce. So you're really, in today's world, it's about elasticity. It's about getting out there quickly. It's about evolving. So friction-free scaling, I say, order constant management scale. Does your management headache increase? How does it increase as a function of the size of the data under management? Incredibly important there. Partition ignorance. Do I have to worry about splitting up my data, or does the system take care of it for me, and what are my choices there? HA and resilience. Is it just sort of baked into the system, or is it something I need to worry about? And then this notion of maximizing return on available data. That's where we'll kind of get into the big data piece of it. Audience analytics is an example of recommendations and such. Okay, so here's the next couple of slides, and I'm going to actually dive in a little bit. The way that I found out of the forest, and this is a thing I do all the time, is say, okay, how do I build a bit of a conceptual model around what's going on here? And it's not to say that this is exactly correct, or it's certainly not the only way to represent this, but I find it to be a great mush separator. And the reason I actually built the first version of the model I'm going to take you through here real quickly is I was having a debate with one of the database analysts, sort of the industry analysts, and walked him through this, and it really had an impact there. So I just want to share a bit of that. So if you think about it, as a conceptual model, it's really pretty simple. So we'll go through this. Just kidding. Now we're going to go through some of it, though. As soon as this switches over. So what I did is I broke it up initially into data model, consistency, cluster, query model. And in the data model, when I talked about persistence ignorance, people understand, if you're familiar with any of the NoSQL systems, that you are going to have relationships, but those relationships will be inherent in the information model of the application. So if you're doing the simple blogging example, you're going to have authors, you're going to have blogs, you're going to have posts, and there'll be a relationship between them. The first level of making things easy is, do I have to join 3 or 4 tables together to produce a customer or not, or can I reason about them in one form? Okay, so that's one form of that. Reducing the need for object mapping, that's a different form in terms of what do I need to think about going from my application model, what I'm programming against, down to the persistence model. And then efficiently supporting schema evolution at scale. Are my schema evolution operations constant time, or do I have to touch all the data? And different forms of data model, we've got blob relational. Document or instance-based and graph. And the other one, key value. I get a question quite often on how do I define the difference between, say, a key value, key attribute, and a document store. In a document store, I consider having, if you will, a collection of entities themselves, which can be complex in the sense that they have nested collections within them. But they have a top-level collection. And whereas in a key value or key attribute store, you typically have more of a flattened representation. You can certainly represent a document as a set of embedded relations, if you will, or explicit relations in a key value store. So just a way to think about this. And in the key value and key attribute space, if you look through all of the NoSQL things, you'll find sort of in-memory centric, Redis and whatnot. You'll find our cache, you could classify as that, or all the way through to sort of disk-centric, which I'd put Azure Table Storage sort of in that category. Okay? And schema management, we talked about that. And then a partitioning model. Is it explicit or implicit? And quite often, many of the same constraints, when I get to sort of the cost of consistency, are at the systems level still there in some of the other models. It's just that the implicit partitioning kind of hides that from you. Okay? So that's number one. And we'll kind of run through a couple of these. We'll go faster. Consistency model, I think everyone has heard the whole acid versus base, basically available, soft state, eventually consistent. The real question to me, and I'll have a slide specifically on this in just a minute, is consistency at what scope and at what cost? And I will actually talk about a couple systems where I believe they've kind of gone too far one way or the other and give you examples. I think that will help in the choice, okay? And how much burden is on the programmer to put things back together if the consistency is left to them, okay? Then this notion of a cluster model. This is mostly about the management aspect. So do I have resilience at scale? The system faults not trigger full cluster issues. Do I have management at scale? I can just reason about one thing and the system takes care of it. In terms of generations of clusters, for those of you who've been around sort of more of the commercial database space, I'd call the first generation sort of the single system image cluster. So RDB, VAX cluster, Oracle, OPS, RAC, whatnot. And then there's a second generation, which is about a separation of the management in the workload plane. So if you think about how SQL Azure surfaces to you, it's an example of a separation of that. So we manage it as a one. Okay, so we deploy to 1,000 machines on a cluster. Just press the button. But you see it as separate specific databases. And then there's the truly elastic with compute storage separation. We have developed sort of an internal, well, it's an external service built on top of the same engine that SQL Azure is that exhibits more of that. And with some of the other federation support I'll talk about in a little bit, you get that as well. And then potential coupling between transparent scalability and the partitioning model. I'm going to come back to that on the consistency and eventual consistency story. Okay, so I'm going to stop right here. Any questions on the first couple of these things? Just because if anyone's confused, we'll stop right now. Okay. Query model, we'll talk about it real quickly. This one won't take long. People want support efficient online queries. I think the thing here is, can you do the rifle shot queries? I want to go down and get the particular entity I need to serve and just pull it out very, very efficiently for many applications. scope, selection, projection, distributed map, reduce, different forms. And what's happening is at different scales for different reasons, and I'll come back to this when talking about map reduce versus traditional sort of data warehousing. Where is the pain, and where's the pain sort of getting addressed and fixed in any of these? So I'm not going to, if you have questions on the query model, feel free to bring them up later. I'm not going to spend a ton of time there. View model is interesting because you can think about a view model in several ways. You can think about it just in terms of an indexing set, and you can think about it as sort of a user-defined views. Many of the NoSQL systems, in fact most, do not have consistency, transactional consistency, asset level consistency with respect to views. So, and some of them are completely batch-centric. So you'll define a job that will create a view and then run it periodically. For a lot of applications, that's fine. For another set, it's not. One of the challenges we have with these systems at scale is with respect to the physical partitioning of the data. You really only get one choice per primary data dimension. And then everything else has got to be partitioned along a different way. So a lot of different things to look after here. Okay, so if I switch back to the slides. The thing I want to just bring up right now is just a couple of choices. So the way that you can get really smart about this and really make decisions, if you go back to a conceptual model and say, okay, based upon the application I'm developing, which of those dimensions are important to me, and which of the systems that I have access to can provide me that facility. And so an example here is, I don't know if any of you have used Entity Framework Code First and migrations. Some hands going up. Actually, the Entity Framework team sort of reported to me for quite a while. In the spring, I kind of wrote a little personal system. It was the first time I ever did anything of any consequence with Code First and migrations. I was really impressed with how, as I was developing the application, that the persistence model could keep up with me at speed of thought. I could just change things in my domain class, just press the button. Once I figured out how to talk to the PowerShell command line in terms of the migration support, and it really, really helped my speed of evolution. So when I talked about persistence ignorance, when I talked about, here we're mapping down into a relational database, but we can set things up such that you're kind of operating at speed of thought without having to have a schism between sort of the model underneath. In this particular case, I did not use the annotations. I have those sort of in the mapping, but I found it very, very productive. So there's just something to think about for folks. Next thing I want to spend is the cost of consistency. And if people want to chat offline, I think I've got a Q&A system. This is one that I find that there are a ton of people who are, don't really have a full understanding of what's going on underneath the covers. The transactional, I'll assert it, and then if you want to come ask questions or challenge me later, feel free to do it. The cost of achieving transactional consistency in a small scale, the way most database systems, and this is not relational, most systems that use a write-ahead logging scheme are pretty advanced in the way that they checkpoint and write, are about as efficient as you can get with respect to disk I/O. Now, by that I mean, a lot of people don't realize, when we commit the transaction, we don't necessarily write anything back in terms of the disk blocks that hold the database, if you will. We just force it into the log in whatever the most compact representation. We write the transaction log serially, sequentially. And so it's super efficient with respect to the disk. And then if we go to write out aspects of the database, we will order things and write them out in skip sequential form. And we also get the ability to keep things in place so that, say, range scans, so structures that we use like B-tree indexes and whatnot, still keep things in place. Okay, so I hear a lot around, okay, log structured file systems and whatnot. Most mature database systems do really, really well at this. So the cost of achieving transactional consistency sort of within a single machine is very, very low. And so you will find above that, in the models, different consistency realms, okay? And the attribute, I mean, is it sort of a field in the entity itself, and then this notion of whether you want to call it a shard or whatnot, and then database rack, whatnot. Doing the traditional consensus-based consistency sort of at internet scale, I think, is crazy. If people want to talk about that, we can check about that as well. Now here's some examples. I think the first version of Dynamo that Amazon did, and I know folks, a couple of folks who were designing it, they did not do entity level consistency. And you had to kind of do it yourself. And there was a ton of burden on the programmer. And the thing for me is that the cost really isn't, it's insignificant between doing it at that level or just attribute level. And so this is where things get pretty interesting. And up into the point where you can partition in shards and stay within a single machine, it's very, very inexpensive, very, very efficient. Okay? And I've got another slide that'll get into that in a second. So there's a feature in SQL Azure DB which is known as federations. And the idea here is that you can have a root database that partitions a set of databases underneath it, and operations within the federated databases are consistent. Operations across are eventually consistent. Now I'm going to walk you through a couple things there. This pattern has been in use for a long, long time. Inside Microsoft, the Windows Live address book is built on SQL Server, built on this pattern. It has tens of billions of people represent, and that's kind of a trick. You say, how does that? Because there are only less than 10 billion people on the planet. But if you look at all the address lists, there are tens of billions of folks represented, addresses represented in there. And it serves hundreds of thousands of requests per second. And it's built on off-the-shelf SQL Server built with this pattern. Okay? And the pattern that we've done here, the system that I talked about, well, it's Exchange Hosted Archive. We have a version of that that was built on the same engine that serves SQL Azure, built with a model just like this underneath. And it is a extreme scale multi-tenanted database. So the first deployment, serial number 1 that we fired off was 770 nodes. And what we would do if we, customers, an individual large customer would be smeared across order 100 machines, 100 of these partitions. And the query forms were such that we could just basically broadcast a query in union all across for some of the queries they wanted to solve for the email archiving thing. So we were way faster than any other solution that they'd tried before. And with respect to eventual consistency, I want to just describe how we did schema changes. So to do an alter table, okay, across this one large database, multi-tenant database, we did not do a distributed transaction. Okay? We ran a workflow that basically did an alter table on each of these partitions, all 770 of them individually. And then we kind of watched until they all did their thing. And then we would roll out the next version of the app. Now, here's why that makes complete sense. This is what I had to sort of work with the existing product team to understand is we don't lose anything. We gain a lot. We didn't lose anything. So if you try to do a distributed transaction across 770 members, the chance of any one of them, you know, having a little bit of a hiccup at any point in time is not non-zero. And if with a workflow, you can kind of make sure that it just eventually gets through. Now, you don't typically transact an application change with a schema change. If you're going to roll out a new version of the app, you make the schema change, typically sort of add a column, and then you roll out the application change afterwards. So if you think about how this overall workflow went, we just make the change across all the members. Once it's been done, they're all in the state, they're ready to accept the new application, we roll out the new application. So we gained a lot in terms of resilience. We didn't lose anything, really, in terms of effectiveness or consistency. Make sense? Okay. So how to choose, okay? My recommendation, wholeheartedly, fully, is, and if you, maybe I can stick to some form of the conceptual model I have up on SkyDrive or something. Send me a mail if you want it. It's davidc@microsoft.com is my email address. Whether you use that one or not, having in your head a conceptual model around what you need to do and how you're going to think about it, it allows you to mix and match. Okay, so it's not a throw the baby out with the bathwater proposition. And the thing is, there's no such thing as a free lunch, right? I mean, you're trading one set of things for another. So being armed and having a model in your head is by far the best way to make a choice here. And I will assert that if you just, the last 2 minutes of what I just said, if that lodges in your head, you're going to walk out of here smarter than most bloggers on this topic, okay? Seriously. And it's just about having that model. And I gave you most of the elements of, you know, how to do it. And you can go test aspects of that yourself. But it is tremendously clarifying, okay? Okay, before I go to the Azure offerings real quick, any questions on that? Hand real quick. Yeah, in the back. Mm-hmm. So, yeah, good question. So the question is, what happens if the alter table fails? In each, it's a good question. In each individual partition, we use a transaction. Okay, so if it fails, it just goes back to the previous state. And the old app the app works against the old and the new state. So it's atomic within each of the partitions, as I mentioned in the previous slide. And if it fails, we just take a look at it. Why did it fail? And more often than not, you just run it again and it succeeds. And so you really reduce the coupling. At scale, and this is the thing. So before I came to Microsoft, Digital had, I think, it was just an amazing cluster system, right? VAX clusters were great in the day, and RDB was incredibly reliable on them. And so we all had this perspective on, what a real cluster should do. When you get up to 1,000 nodes per cluster, everything that you held as true and sacred is no longer true. And so actually, here's a little snippet. When we were sort of doing, if you will, advanced development on what became sort of this Cloud DB engine. And as I was hiring people for it, I began to look for people's ability to unlearn. Because I would tell some of the developers, hey, you've been working on SQL Server for 10 years, and 3/4 of what you know is still valuable, but 1/4 of it's going to get you into trouble. Your job is to figure out which is which real fast. And it's the truth. I mean, because the things that used to be second and third order dominate, at these scales. So it's a good question, though. Okay. So with this, we'll start talking price. At scale, I'm going to have a slide in a few minutes that will assert that the cost of storage is kind of going to zero. But when you get into hundreds of petabytes, that's not true. Azure Blob Storage, those guys are doing a great job of driving down, because you can optimize along a number of dimensions. They're optimizing and driving down along a cost and reliability dimension. So instead of using a parity-based redundancy scheme, form of RAID, they're actually now doing erasure coding. So error-correcting codes, if you will, in the data to reduce the amount of redundancy, just drive. So there's a lot of real good work going in there. And so, to be a place where you can just place data and then be able to lift the value out of it later. We'll come to that in a few minutes. Azure Tables is a form of key value. I refer to it as a key attribute store because the value is not completely opaque. Okay, so you have a key, and then you've got a set of, if you will, attributes that are specified in the data model of the system. That, to me, the distinction between a key value, where the value is typically just completely opaque with respect to the storage system, to a key attribute system. Azure Caching is, I talked about an in-memory versus disk dimension along these key stores, is a key object cache more than anything else. And Azure Database, Elastic RDBMS with sharding capabilities. And what we want to ultimately achieve with Azure DB is if you are a software as a service vendor, people are going to want different tenancy modes. So TFS, the TFS service, which Jason Zander introduced on Tuesday, is built on Azure DB. And Brian Harry is the technical fellow who developed that. We've got a couple of models where we can he's implemented a multi-tenancy model inside a single database, so you can get really, really dense, or basically provisioning a database per tenant. Okay, so we could spend an hour or two just along the multi-tenancy dimension, sort of its resource isolation versus a sort of a guarantee of an efficiency sort of play. So costs in there. So the other thing I'll say, which is fascinating for us as a team, when we were working on the boxed products, we didn't have to think about the costs of running these things. And unfortunately, you did as a result. Now, we're learning a lot around what it costs to run thousands of these things and in thousands of servers and data centers around the planet. So there will be value for you in the sense of what we learn there, how much of that translates back into the on-premises box product as well. So it's really a fascinating time for us in that. Okay, second stanza, big data. Okay, here's the top level value flow. Okay, and when I started going out looking at the big data stuff 2 or 3 years ago, my first objective was, okay, is there anything new here? Is this just sort of a complete hype thing? Okay? And what I found quite quickly was the early adopters finding new, distinct value. Okay? And now there are lots of examples of that, but that was, still something I wanted to validate. I think the flow goes as follows, and I'll just drill into this a couple steps, next couple slides. We're just awash in ambient data. Even inherently analog phenomena are born digital. You talk on your cell phone, it's going over a digital network. You take a picture, it's encoded digitally. And so being able to store that ambient data, and then this thing I call information production. This is the one piece where sort of the data, hardcore data warehouse guys don't see. Okay, and the trick here, I'm going to really, really try to land this one, so there should be no confusion by the time we're done, is about taking information or data in one domain and transforming it into another. And I'm not going to spend a bunch of time explaining that right now because it's going to become really clear in a few minutes. And then turning that into insights and actions. Okay, that's what the whole flow is about. So here's how this works. The cost of data acquisition has gone to zero. And a couple of years ago, when I was trying to make this point to folks, I looked and got data from Bureau of Labor Statistics, a couple other sources. In the US a couple of years ago, you could find people who would still type stuff in for you. And whether it was manuscript typing or data entry, it's about $1 a kilobyte. Okay? So at that rate, it costs you about $1.10 for the Gettysburg Address. It costs you about $1,000 for someone to type in Moby Dick. And it costs you about $1 billion to fill a terabyte hard drive. Okay? So it's $1 trillion per petabyte. And as we said the other day in sort of our online services, we're processing hundreds of petabytes a day. Okay? So this is not all coming off people's fingertips, obviously. Okay? So we've gone from $1 billion a terabyte to, in essence, $0 a terabyte to acquire the data in 30 years. Data storage costs, and I actually have here's the source at the bottom. This is inflation adjusted. So in the last 30 years, we've gone from $660 million per terabyte. That's just to buy enough raw hard drives to store a single copy of it to order $100 a terabyte or less, depending on where you're going these days. So we've gone from $1.6 billion a terabyte to $100 a terabyte in 30 years in terms of the acquisition and just the most basic storage cost. Okay? So if you say, can we do something different when we get a 1.6 billion to or 160 million to one shift? Yeah. So the big data workflow is about acquiring these ambient data, sticking in something I call a digital shoebox, and then doing information production to feed either traditional systems or emergent systems. And I'm going to spend a little bit of time on this slide, because if you get this, then the next sequence will make complete sense. So when you store things in this model, you don't spend a lot of time building a domain model over it. Okay? There's a natural acquisition model. And I'll show you the natural acquisition model out of my GPS logger. Another thing to think about, and this is a way that I sort of broke through with one of our architects. I asked him one day, because he was saying, look, we get big data warehousing systems. Why do you? I said, how do you store a copy of the web? He looked at me, what? I said, how do you store a copy of the web? And he's like, well, what do you want to do with it? I said, I don't know yet. And so I said, keep it simple. It's just static HTML. I think the acquisition model for that would be, it's the URL that I fetched, timestamp, and then the HTML. Okay, just keep it really, really simple. Then you come along sometime later and say, I wonder how many pages change on Microsoft.com each week. You could just go through and using the timestamps, restricting on the domain, figure out sort of the page turn. You could say, I want to build a big graph of URLs. I could go from a target URL. I could go crawl all the finite anchor tags, href attributes, build this graph and stick it somewhere else. I could parse the text and turn it into an n-gram representation and store it in one of a variety. That's information production. Didn't know what questions I wanted to ask. Didn't spend a lot of time in the modeling. Just threw it there. Okay? And if you're a real data warehousing kind of guy, the other thing I find kind of fascinating here, and this is, I'm not going to spend a lot of time for folks here. If you store and buy into this model, you wind up with a lot of resilience against slowly changing dimension sort of things, because slowly changing dimension models are lossy in some form. So it is really kind of an interesting way to think about it when you get through it. Now, here I'm going to make it real. Here's the standard data analytics lifecycle. Typically, I got a question. Oh, I got to go collect the data. I got to build a logical model, physical model, load the data, tune it, and then I can answer the question. Sometimes weeks or months later. Okay, some heads nodding. People know this well. But if you think about how, as humans, we want to work with a new question, we simply want to validate it. Hey, is that an interesting question to even ask? And if it's not interesting, we'll stop right there. But if it is interesting, is it worth asking again? And if it is, we'll make it repeatable, we'll clean it up, and we'll put it into production. And so we can answer it, 1,000 times a day. So let me overlay that previous piece here. In using today's sort of standard data analytics lifecycle, it takes you weeks or months to get from a novel question to be able to even validate it. Okay? And that is sort of where the value is. Now, at Microsoft, we went through our own sort of big data evolution. We ran our online services in sort of a traditional sort of thing. We built a data warehouse. We had ETL flows all over the place. We had and the researchers, the people trying to derive new value out of the data, they'd have a flash of insight. And they'd say, oh, it's not in the model. I'm not going to go ask those guys. It's just going to be weeks before I can go get all ETL changed. I can get a stage. When we opened things up and had a big data processing environment over this large digital shoebox, you could have a flash of inspiration in the shower and come back into work and actually ask the question. Now, it might take 2 hours by brute force to validate it, but if you compare that to 2 months in the old way, it was a tremendous, tremendous shift. So it is doing, if you will, just in time or deferring all of the modeling, which is where a lot of the value is here. Okay, that's a really, really important point. So now I'm going to make a transition into sort of some personal examples. This is sort of kind of what I've showed. And these next few slides really hammer home the point around information production. So I was just walking around with this GPS logger. And actually, if I go over here, if you look at this section right here, where the highlighted row and the one beneath it, it shows, or the highlighted row and the one above it, north 42.3, west 71. That's me getting in the airport on an airplane in Logan Airport and flying back to Seattle. Now, the curious thing about that is I get on the airplane at 6:23 p.m. I land here at 12:48 a.m. And the first reading the GPS logger takes is from Boston. And then it looks like I go 2,500 miles in a second and a half. Okay, so clearly there's something going on there. So what I've done in my processing is built sort of a filter to take care of that, take it out. So quite often you'll find that you're cleaning things up as you go. One of the other things I built is knowing when I was stationary and where I was stationary. Okay, so I just wrote a little MapReduce job that would go filter stuff, and I'll show you, some of these in HD Insight, sort of the MapReduce stuff we announced last week. Final thing I did, which is kind of cool, I'll just show you the results of it, won't drill into it, is I built sort of a geospatial, almost like a regular expression. So if I'm at home at rest and I follow a particular set of potential paths to work, and then I'm at rest at work, it represents a commute to work. Okay? Then what I can do, and I think I have this on the next slide, is I can then plot my commute time as a function of when I leave the house, or plot my commute time as a function of the day of the week. Now, here's the information production piece. Okay? The representation that allows me to group by time that I leave, day of the week, month, it's a single representation. Okay? So that can go into a relational database, whatever else you want to do, and I can write SQL queries over that. Getting from just this stream of GPS telemetry into what's a commute to work and how long was it, and what's a commute home and how long was that, I defy anyone to write the SQL queries for that. Okay? So that's the information production. Transit from one domain to another. Okay? Just to make this real, I'll give you another example. So part of what's going on with a lot of these data, these ambient data, they represent event streams. So GPS telemetry. Another event stream I produced was out of my Outlook. When do I send mail? So I went through all of my sent mail. And then if it's a response to someone else, what's my reply latency? Okay? And then I just joined them. So if I take the dwell geolocation and I take the outlet statistics, I can say how much mail do I send when I'm at home versus when I'm at work. And the sort of the cheap way to get a laugh here is I tell people, yes, this is consistent with my wife's intuition, but I haven't shared the results with her. So Okay, so what's the big deal with this MapReduce stuff? Okay, it's a developer-friendly information production machine. Okay, it's really easy for developers to understand, to develop for, and it's inherently scalable. Okay, and this is everything you need to know about MapReduce on one slide. Okay, sort of the conceptual view. Okay, and as a developer, all you need to do is implement two simple functions. We'll show you a few of those because we'll actually run some of this stuff in a second. Write a map function and a reduce function. And you point it at where the data is going to come from, and you're going to point it to where you're going to put the results. The underlying system splits the data and invokes any number of map jobs. Okay? Each one of them runs completely isolated, doesn't require any state from any other, so it's inherently scalable. Okay? And then the map, after running all of the map jobs, the MapReduce infrastructure collates all of it. So the map jobs, your job, all you need to implement is a function that takes whatever input you decide you want your process, and it produces 0 or more keys and values. That's it. You just hand it off. Then after all of the maps are run, the MapReduce infrastructure collates all the keys. Now, sorting is one interesting way to collate, but it just needs to produce a partition. Then for every key that is distinct, it just adds on all of the values. Okay? It just strings them all together. Then turns around and calls your reduce function, which gets a key and a set of values. And then you do whatever you want there. And the shuffle in the middle is where the MapReduce system can do that in a distributed way. There's an optimization called a combine, in which you can run the same reduce function before doing the shuffle just to reduce the amount of data that the system has to shift around. That's strictly an optimization, and the processing that you do between the map and the reduce function needs to be associative and commutative for that all to work in the end. And you have to produce the same result whether the combine gets run or not. Okay? Then the output just gets written out. Simple as that. And so one thing I could, no, I'm going to keep going because you'll get this in the code. Okay? So last week, we announced this thing called HD Insight. This is Hadoop on Windows Azure, Windows Server, and the laptop version. So if you have just get the web platform installer and install, Microsoft, I don't know what the actual name in there is, just look for the recent one. It's HD Insight. It's based upon the Hortonworks HTTP distribution. It has a native .NET MapReduce API. I'll show you that in just a second. And we also have, if you're familiar with Hive, which is a SQL-like query processing facility over Hadoop. We have a link query comprehension syntax. So you can write, in the tool I love using is LinkPad, thing I showed in the keynote the other day. You can write link query comprehension syntax, which we will translate into Hive query language and then submit on your behalf. So if you're a link guy, you're a .NET guy, life's good. Okay? And so now, let's look at some code. So I'll go back over to VGA1. We'll bring this up. First thing I'm going to show you is sort of the mapper that I did here. Okay. Actually, let me go over here. The file that winds up getting produced when I stick this in USB, my little GPS data logger, looks like this. Okay. It's got this point. The first value here is a timestamp, number of seconds since that infamous January 1st, 1970. And then it's just lat long. I think it's an elevation, might be in meters. And then this last value out here represents, this is the first reading it's taken since the last one, and I think it's actually the old value. This is where the shift from Boston actually finally I attributed it to. So we're only going to take values that have zeros out here. Okay? That's the input file that we're going to process. And so our map gets called once for each one of those lines, including the header line we just showed, which we're going to ignore. Okay? So here's all I need to do in the map function. There's some counters so we can trace things through this, and I'll show this when we fire it off. I just look for lines that start with point, then I just parse them. So I split the line, at the first equal sign, which is over here. You can see that right there. Okay. Then I just split it on the commas, and then I've got a little function here that just converts the time just by adding a number of seconds since our base, if you will. Okay. Then I just emit the columns containing the timestamp, latitude, longitude. Okay. So here's the key. I just produce a key, produce a value. Here are cases where I don't produce any. So remember I told you can produce 0 or more? So sometimes it gets called we don't produce any. All right? So that is the mapper. It's as simple as that. Okay? Now, having mapped, now what I wind up with is a key. Now, the key, I should state, is just a date in month, day, year. Yes, question? So the question is, if I had the brilliant idea in the shower, I have to run the map. No, here's the thing. At scale is an inherently scalable system. So even, and it's all done by brute force scale out. So let's say in our environment, our online processing environment, we're processing over one pool, one of these digital shoeboxes, which is order tens to hundreds of petabytes. And those jobs will still run in a couple hours because it's massively scaled out. Okay? So now it's not going to come back in a quarter of a second, typically. But 2 hours versus 2 months to try to do it the old way, that's where all of the value comes in that phase. And it's developer friendly, and then it's really easy to wrap your head around how to go do what you need to do here. So now let's take a look at 2 different reduce functions. One is just the daily average. So all I did here, so here you get, I was going to show you this, you get call, let me make this a little bit bigger, with a key. And remember I said that the MapReduce infrastructure just gives you a collection of values. So here are the values. All I did is went through this and computed an average lat long per day. Simple little thing to do. And what I'm going to do is just, let me just make sure which one I have set up down here. So the .NET interface lets you specify a configuration. And you execute a job, you specify the mapper and the reducer. And right now I'm doing the average one. I have another one here, which I'll just show you real quickly. Oops, that guy should be able to go to him. He might be, he's off in another project. Let me go back over here. Daily range reducer. So this one's just finding a bounding box for sort of where I was for every day. Okay, and I'm going to just run one of these and just show you what you can see as you do this. So when you install HD Insight on your laptop, you wind up with this nifty, where is it, 8085, I think is the one I don't use. Oh, it is there. Okay. This is exactly what you see if you go to the Hadoop on Azure service, HD Insight on Azure. So you've got it right here running locally. And in here, we've also, as I mentioned the other morning, we have a JavaScript interface. So if you're in a JavaScript, you can author MapReduce jobs in JavaScript and go off and do it. You can run Hive from here. But the place I want to go to is, did I have it over here? Localhost 5030. Okay, so this is sort of the job facility. You can watch them all run. You can tell that I got up early. The first job I ran this morning. This was before the shower, 3:38 this morning. So I had the insight before the shower. And then you just run through, and you can go in and anything you log, you can take a look. You just show the output from these jobs. Here's sort of showing, I'm just emitting the logs, showing what I'm ignoring. So you probably saw that in the code as I did that. So this goes off and runs. Now, having done that, what I want to just show you really, really quickly, I just then slurp it into Excel. Okay, so I've got a date which is encoded, and I didn't encode it as an Excel date for a particular reason. I'll show you in a second. Latitude and longitude. Then, you get to see some of my PI. Here's where I've been. The average lat long for me over the last few months, I've been keeping track of this one. And I just did it in PowerView. Just said insert PowerView. You tell it, where's the lat long, and away you go. So very, very easy. latitude and longitude. Okay, now, the other one I did was basically, I computed the bounding box and then the range of it. What's the diagonal distance across that? And so this one I think I just did for 2011. And here's the interesting thing about this. There is as you go through these generation of insights, visualization of different forms are how you really get the insights. And in this particular case, this is my range for sort of the first 3 quarters of 2011. So you can learn something about me, that I was doing a lot of traveling around 2,400 miles in distance. And that's because my wife decided she was going to move to the East Coast on me and said I could commute. So that's because I was doing too much email at home instead of going to work. So no, we're still good, but I spent a lot of time on an airplane. Okay, so with that, that's sort of the quick run-through for the MapReduce stuff, okay? So the trick here, actually, let me share one more story with you. So part of my job is to, okay, figure out what the heck's happening, and then what should we be doing about it, right? And so last year for me was, okay, we've got the story down, we understand what's going on in sort of the big data space. I wanted to schedule a couple of big talks. I did the one at the VLDB conference I mentioned earlier. And then I said, okay, I want to be able to talk to the techies, the CTOs, the guys who are doing the projects in the sort of advanced development in some of the companies we work with. Then I want to get the story all the way through where I can talk to the CIOs who aren't going to fully appreciate the technology. The folks who were the hardest nut to crack, okay, were the enterprise data warehouse guys, okay, who had the view of like, none of this stuff is worth crap unless it's in my data warehouse, okay? I got the one version of the truth. And they were the toughest nut to crack. Until about, I don't know, 6, 8 months ago, I finally stumbled on something that now I can just get through all of them. I said to them, that's a very, very fine version of the truth. And it's still super valuable. I said, but in this new world, there's a version of the truth about what people are saying about your products and what they think about your brand and how that's playing out in the online world. And that's a different version of the truth. And I said, another version of the truth is available from all of your operational systems, which are just spewing out data. You just got data coming out of everything. And there's yet a third version of the truth or perspective that you can get out of those systems. And I look at them and I say, and if you're looking at one version of the truth, and even if you're doing better than the other guys, but you're not looking at those other 2 versions of the truth, and your competitors are you keeping up? And oh, yeah. And so even those guys, and you actually see it. There's a lot of recognition of this now. So it is real. There, of course, is hype. But again, I've tried to arm you here. The trick in this, okay, there's nothing magic. The magic is about deferring the modeling and to be able to do the information production in a very quick and efficient way. And having things sort of pop out with you that you subsequently refine. Okay, so with that, we've got like 6 minutes for questions. So someone's got to go first. Yes?
So your for loop that you made to go through the initial file,
Mm-hmm.
that wasn't the scale up. So the scale would be to break it into chunks and send it off to the 1,000 machines.
Yeah, but I didn't have to do any of that. The MapReduce infrastructure does that for me. It splits it all up and then just calls the map functions across the entire cluster. And they're all isolated, okay? They just have to look at that little piece and produce keys and values. That's why it scales. It's, as we tend to say, scale-free. They just keep going when you're scaling. There's no coupling between it. Now, the shuffle is where the infrastructure needs to do some heavy lifting sometimes. And that's why the combine is in there to optimize. Yeah? I'm sorry, can you just repeat the last couple of words? Yeah. Yeah, okay, so yep. Okay, so let me see if distill the question. So he said, okay, this stuff is sort of front-end in the analytics, you're a developer, this and that. When does it come to the masses? I think the most straightforward answer to that is part of the information production process is to turn it into a form which is consumable by the masses. The thing I didn't go into one of the things that I do when these shifts take place is try to go out and figure out where all the early adopters are and what sort of natural patterns fall out of what they're doing. One of the natural patterns, if you remember that digital shoebox picture, is you wind up with a constellation of data marts and data warehouses and other things around it that are more traditional systems that you can use all the existing tools on. So just as I turned something crazy into a form that was really easy to then reason over in Excel, you can do that. That's answer one. Answer two is trying to democratize and domesticate sort of the upfront stuff, because there's exploratory analysis and exploratory visualization and explanatory analysis and visualization, and those sort of nest within each other. So we're working on tools in that space too. But the most straightforward and direct answer is much of information production lands stuff in ways that it can be consumable by existing tools. It's just hard to produce any other way. Okay, that's a good question. Another one. Yep. Yeah. Yeah, that's a great, great question. We could spend a day on that one. But the question, just in summary, I talked about this really, really simple natural acquisition model versus a scheme where you say, I'm just going to, at some level, model everything, a la semantic web, and then life will be good. Okay? I don't, just to be blunt and direct, I don't buy that second thing. The range of common knowledge, to use it in the formal sense, that's required to make that, I think, scale is just non-tractable, my opinion. And here's a real conversation which I think illustrates some of this. I had a conversation with a very large life sciences company a few months back where they had a number of drugs that were kind of at the end of their IP, their patent protection. And one of the ways that they could create new value is to find alternate uses for them, other positive side effects. And what they want to do is go back over several decades of clinical trial data to see if they could unearth some of these. And their original approach was to build a single unified data model and and then their head started to hurt. And I said to them, okay, in this world, defer the modeling, okay? And here's an example. This is real in the conversation. They said one of the things that you would think would be simple, but isn't, and most people who deal with this stuff will know immediately, just gender. Okay, it's encoded MF, male, female, and there are multiple states, right? And in fact, I was talking to someone from a Blue Cross organization, California. They had over 10 distinct states for gender because they encoded male, female, trans, and various phases. And how do you harmonize all of that? So what I told them was, okay, you just need to do resolution of the data model to the point where it supports the hypothesis. So just pull together, reason about what you need to. So for example, here in the examples I showed, I didn't really, actually, I will show it to you because it's still up there. If I look at this, first time I put the location map up there, if I zoom in, I'm like, what the heck's going on here? I was not in Arkansas. Okay, or Oklahoma, and but I was traveling to Florida. My mother lives down there, so the average. I started here, wound up there. That's when I did the range sort of thing to go off and do that. So I didn't need full resolution on it. It evoked another question that I did some different information production for, and then I could decide I'm going to build a crisp model I can reason about over all of that. So that is where a lot of this value is in deferring that modeling. Good question. We've got time for another one or two. Yep. Mm-hmm. Yep. Yep. Okay, I'm going to interpret the question the way I want to interpret it, and I think it is still answering. So my interpretation, because Okay, if I go off and I do this code first sort of thing, I'm going to wind up in the relational model, have all sorts of nulls, because that's how I can sort of alter the schema in constant scale. Now, okay, do I wind up with a mess there? Would I be better off using a document storage thing and then finally do it? My point is, you can do the exact same workflow, just there's a development phase where it's rapid innovation, the schemas, and then it starts to solidify. And then you can just do one migration, which basically produces the first production version of the schema. And so there, and again, I'm going to wind all the way back. You know, if you have this notion of the conceptual model in your head, both of those options would seem viable, and based upon what you're really trying to do, you can choose one over the other. So, okay, I'm getting the little red light thing up here, and I'm over. So I hope you found something of use in here. I'm actually supposed to go to some question thing, so.